Welcome to Bonding Basics. We're going to take some notes today on exactly how ionic bonds and covalent bonds look when we're talking about how atoms of different elements combine. To start that, we need to go over some information about some of the atoms that we're looking at today. To do this, we need to fill in this chart related to chlorine and potassium and so on. We need to know their atomic symbol, the total number of electrons they have, the number of valence electrons they have, and from that we can figure out how many electrons they need to either gain or lose to fill their outer shell, and then from there we know their oxidation numbers. So to do this, it's always handy to have your periodic table nearby. Make sure this is ready as we go through, and then you can kind of follow along. In future assignments, I'm not going to be giving you this information. You're going to have to figure it out for yourself. So, let's start with chlorine. Chlorine's atomic symbol is Cl. It has 17 total electrons. And if we switch back over to the periodic table, you'll see here chlorine is found in this place in the periodic table. It has an atomic number of 17, which means 17 protons, and also 17 electrons. Its valence number comes from its group number. The group number here is 7. Even though it says 17, we can kind of exclude these that make up most of the transition metals. Actually, 3 there. So we have group 1, group 2, and then we have group 3, 4, 5, 6, and 7. So chlorine has 7 valence electrons. Remember, group 8 is what we're trying to get to. So, alright, so back to chlorine. Chlorine's atomic symbol is Cl. It has 17 electrons. It's in group 7, which means it has 7 valence electrons. And in order to move up to group 8, it needs to gain 1. So we're going to put a gain 1. And that gives it an oxidation number of -1. Since it has an oxidation number of -1, that means, remember, that it's going to have one extra negative thing, and the electrons are what are negative. So we need to gain 1 negative. Potassium. Potassium's atomic symbol is K. It's found in the 19th block in the periodic table. It's found in group 1. And since potassium is in group 1, it needs to lose 1 electron to have a full valence shell. So unlike chlorine, potassium has a +1 oxidation number, or a +1 charge. Notice which side of the periodic table these two things are from. Chlorine is from the right-hand side of the periodic table, so it's negative. Potassium from the left-hand side of the periodic table is positive. Okay, moving on to magnesium. Chemical symbol is Mg. 12 total electrons. It has 2 valence electrons because it's in group 2. And therefore it's going to try and lose those 2 electrons to be full and happy. So it has a +2 oxidation number. Fluorine, on the right-hand side of the periodic table, is atomic number 9. It has 7 valence electrons, which means it is going to gain 1. And just like chlorine, fluorine is going to have an oxidation number of -1. Moving on down, we have aluminum. Aluminum is periodic table number 13. It's going to have 3 valence electrons. It's going to lose those 3 electrons, which gives it a +3 oxidation number. Sodium, one we use all the time. Sodium is Na. Sodium has 11 electrons total. It's in group 1, so it has one valence electron, which means it's going to lose one, and that gives it a positive 1 oxidation number. Another frequent element is nitrogen. Nitrogen is number 14 on the periodic table. It has 4 valence electrons, being in group 4, so it wants to gain 3. So it has a negative 3 charge. Our next is oxygen, number 8. This has 6 valence electrons, wants to gain 2. So it has a negative 2 charge. And then we have hydrogen. Hydrogen has 1 total electron, and so to have a full outer shell, it needs to either gain or lose 1 electron. So hydrogen can actually be a +1 or a -1. That's a +1, not an H there. Our next is carbon. Carbon has 6 total electrons, 4 in its valence shell. It can either gain or lose 4. So it has either a positive or negative 4 charge. And finally, iodine. Iodine, all the way down, number 53. This is in group 7, so it has 7 valence electrons, which means it needs to gain 1. And so that'll give it a -1 charge. Again, all of this can be found on the periodic table. You just have to know how to read it. So moving to the next step in the process. An atom that gains 1 or more electrons is going to have a negative charge. An atom that loses 1 or more electrons will have a positive charge. An atom that gains or loses 1 or more electrons is called an ion. And we know that a positive ion is called a cation, while a negative ion is called an anion. So then we move these ions into something called an ionic bond. In an ionic bond, atoms will transfer 1 or more electrons to another to form the bond. Each atom then is left with a complete outer shell. So some are getting rid of electrons to gain that full outer shell, while others are keeping electrons to get that full outer shell. That forms an ionic bond between a metal and a nonmetal. So if we draw these, we'll use Lewis dot structures to draw these. We're taking a look first at sodium and chlorine. Sodium, as we've already said, has 1 valence electron. Chlorine, on the other hand, has 7. That means the 1 valence electron from sodium will go to chlorine, whereas chlorine will gain 1 valence electron. So now sodium is down 1 energy level, and chlorine has gained an electron to make its final energy level full. Our next example is magnesium and iodine. So magnesium has 2 valence electrons, and iodine has 7. Since magnesium has 2 electrons to give away, it's going to pair up with 2 different iodine atoms, each of which has 7. So we'll find 1 electron goes to this iodine and 1 electron goes to this iodine. So that gives you an idea of the final formula being magnesium, iodine, which would have 2 iodine atoms. Moving on to the next page. Next one we have is potassium iodine. So potassium has 1, iodine again has 7. So potassium gives its 1 electron to iodine. Sodium and oxygen. Oxygen has 6 valence electrons if you look at our chart. So it needs 2 more electrons to be full. Sodium, unfortunately, only has 1 to give. So we need 2 sodium atoms in order to satisfy oxygen's needs. Our next is aluminum and chlorine. We'll skip down to here. Aluminum we saw has 3 valence electrons. Chlorine has 7, so it needs 1. So that means we have 1 aluminum electron going to chlorine here. But we still have 2 more to get rid of for aluminum. So that means we are going to bond with 2 more chlorine atoms. And now both ions have their full valence shells. Okay, our next example is calcium and chlorine. And even though calcium wasn't on our original list from the beginning, calcium and magnesium are found in the same group, so they act the same way. Calcium has 2 valence electrons, it's in group 2. Chlorine has 7. So 1 of calcium's electrons will go to 1 chlorine ion, and the other will go to another chlorine ion. So that is what we have for ionic bonding. Now we can take a look at covalent bonding. Covalent bonds, in covalent bonds, atoms share 1 or more electrons with each other to form the bond. Each atom is then left with a complete outer shell, which is what they want. And remember that covalent bonds form between 2 nonmetals, and they're not making compounds, they're making molecules. So these molecules don't stick to more molecules of the same for the most part, unless it's a polar covalent bond. They just kind of all exist in the same area. So if we take a look at some examples using our Lewis dot structures again. Hydrogen bonding with hydrogen makes a molecule of hydrogen. Hydrogen is one of the elements that is always found in molecule form. You'll never find a single element of hydrogen. So hydrogen has 1 valence electron. So we need 2 valence electrons to kind of make that shell, make that outer shell full. So what we finish with is an H2 molecule. Water, hydrogen plus oxygen, is similar. Oxygen has 6 valence electrons. And to make this a little easier, I'm going to switch colors for hydrogen. So we need a hydrogen electron in this spot, and we need a hydrogen electron in this spot. And since hydrogen only has 1, you can see how we're forming a particular shape. So hydrogen and oxygen share those and those to make a full outer shell. And we end up with H2O. Moving on to the next page, Chlorine is another one of these atoms that never exists on its own. So chlorine and chlorine always exist as a molecule. They are going to share this last pair of bonds. Chlorine having 7 valence electrons. So this atom gets to share and this atom gets to share. Oxygen, another case of having an atom that only exists in molecule form. And we're bonding 2 nonmetals together. Oxygen actually has a double bond. So since oxygen has 6 valence electrons, it needs 2 more electrons to share to have a full outer shell, but that means both have to share. So we have 2 electrons from both oxygens being shared. So now oxygen has 8 and this oxygen has 8. So when that is written, you see 2 lines and the chemical formula or the molecular formula, and that shows that it has a double bond. Okay, moving on to carbon and oxygen. So we have carbon. Carbon has 4 valence electrons. It is going to form 2 double bonds with 2 different oxygen molecules. And if we look here, oxygen has 8 when it shares with carbon, as long as there are 2. So this would be CO2. And if we're writing the molecular formula, there would be a double bond between each oxygen and the carbon. And finally, we have CH4. So starting with carbon, each hydrogen that it bonds with supplies 1 electron to the configuration. So if we finish out, we've got 1 hydrogen here, 1 hydrogen here, 1 hydrogen here, and 1 here. Okay. If you have any questions, let me know.